Alright, so today we're talking about factoring perfect square trinomials and the difference of two squares. So a perfect square trinomial, I'll just put PST for perfect square trinomial. There's two of them. There is a squared plus 2ab plus b squared. And then there is a squared minus 2ab plus b squared. If we were to factor this out, we would have two binomials, a plus b times a plus b, which is the same thing as a plus b squared. So that is a perfect square trinomial. If we look at the second one, a squared minus 2ab plus b squared, we would end up with a minus b, a minus b, and as you guessed it, we could write it as a minus b squared. So when you are looking at the examples, make sure that you are looking for a pattern. So look for a pattern. Let's write that down. Look for a pattern. So let's look at an example, this first example here. If I have x squared minus 12x plus 36. So we are looking at our first term, which is a perfect square because it's x times x, and we are looking at our last term, which is also a perfect square, which would be 6 times 6, factored out as x minus 6 squared. And then you always have to make sure that you check it. So x minus 6 times x minus 6. Do the FOIL method. X times x is x squared. X times negative 6 is negative 6x. Negative 6 times x is negative 6x. And negative 6 times negative 6 is positive 36. We have like terms here. So yes, we end up with x squared minus 12x plus 36. Check. That is a perfect square trinomial. Let's look at another one that might trick you into thinking it's a perfect square trinomial. 100x squared plus 10x plus 1. So if we were to look at the first term, yes, it's a perfect square. If I do 10x times 10x, I'll get 100x squared. And our last term is also a perfect square because 1 times 1 is 1. And you would think that it would be written as 10x plus 1. So then we need to make sure we check. So if I have 10x plus 1, squared, I forgot my squared, there we go, times 10x plus 1. And if I do the distributive property, 10x times 10x is 100x squared. 10x times 1 would be 10x. 1 times 10x is 10x. And 1 times 1 is 1. So we do in fact end up with the first term and the last term correct. But if you notice our like terms here, we end up with 20x in the middle. So we have 100x plus 20x plus 1. And if you notice, plus 20x, we needed a plus 10x. So therefore, this is not a perfect square trinomial. So don't let them just trick you. So let's look at one where you have to look for a GCF first, and then factor. So let's look at 5x squared plus 20x plus 20. So if you'll notice, 5 goes into 5, 5 goes into 20, and 5 goes into 20. So that means that we can factor out a 5, and that would leave our x squared plus 4x plus 4. And if you want to make sure that you factored it out correctly, think about, if I did the distributive property, did I factor this correctly? 5x squared, 20x, and 20. But now that we've done that, now we factor this part. So if you notice, we have a perfect square in the front term and a perfect square in the last term. So this would be written as 5x plus 2, x plus 2, which would be written as 5 times x plus 2 squared. Now let's look at difference of two squares. They are written in the form, they are formed from a plus b times a minus b. And when you do the FOIL method, you end up with the a term squared minus the b term squared. Alright, so let's look at an example. If I have x plus 4 times x minus 4. Now, if you know the difference of two squares, you will know that this is just x squared minus 4 squared. But I'm going to show you why you end up with that. So if we do the FOIL method just like before, we have x squared, x times x is x squared. X times negative 4 is negative 4x. Positive 4 times x is positive 4x. And then 4 times negative 4 is negative 16. So right here, you will notice we have a minus 4x and a plus 4x. So those cancel each other out, or you'll end up with a 0 there. And all that is left is x squared minus 16. And 16 can be written as 4 squared. And there you go. That's your difference of two squares. Let's look at an example. Another example, 225 x squared minus 81. And if you notice, 225 is a perfect square, 225 x squared is a perfect square, and 81 is a perfect square. And the most important part, you have a subtraction, difference of two squares. So difference means, of course, subtract. So 15 times 15 is 225. So this would be written as 15x plus 9 and 15x minus 9. And that's it. Because once we do the FOIL method, I'll do it just so to show you. 15x times 15x is 225x squared. Here's our positive 15 times negative 9, and here's our positive 15 times positive 9, and that's why those cancel out. And then we have negative 81, 1. Difference of two squares. So let's look at one that might trick you. It's not going to trick you because I'm showing you and you're going to know now. What if you had 49x squared plus 25? So what are you going to be looking for? Is the front term a perfect square? Yes, 7 times 7. The last term, 5 times 5. But if you'll notice, we have a plus sign here. And remember, it's supposed to be the difference. It should be a subtraction sign. So this would not be an example of a difference of two squares. Prime over integers. Okay, our last example. This example is going to be one where you have to factor out the GCF first, and then do your factoring. So this example, let's say we have 3x squared minus 75. 3 and 75 have a greatest common factor of 3. So that means I can factor out a 3. So what do I have left? I have x squared minus 25. And if you'll notice, perfect square in the front, perfect square in the back, and then we have our subtraction sign. So how would this be written? It would be written as 3 times the quantity, x plus 5, times the quantity, x minus 5. And there we go.